9.3. Excuse me. We're looking at using tests wisely. So there's a couple things that it's gonna be used to determine sample size. One is our significance level. Two is going to be the effect size. And three, power. All right, so let's go to significance level first. So this is how much of a type 1 error are you willing to have? So if a type 1 error is bad, such as death, then you're going to want a lower significance level, right? So if type 1 is bad, we're going to use something like this. If not, then our significance level will be 0.05 or 0.10 or something along those lines. All right. Using a higher significance level, would decrease the type 2 error probability and increase our power. Okay. All right. So the next one is our effect size. How large a difference between the null parameter and the actual parameter value is important for us to detect. So how large a difference between the null parameter and the actual parameter value is important to us to detect. Okay, what we're looking at is something like when we did that sandwich question a couple videos ago, where it was we had a 6-inch sandwich, but we ended up looking at it and it was something along the lines of 5 something. So how the effect size is how much the difference is going to be in there. Okay. All right. The power. What chance do we want our study to have to detect a difference of size we think is important. So just basically, how strong do we want this to be? Is there going to be a difference between everything that we do in the previous chapters or in the chapters to come? We're going to really emphasize more of the power that we're going to be looking at. Okay, so we're going to do an example next to try and clarify some of this technical stuff that we have to cover. So I'm going to pause it. Well, you guys will get to see it just quick. Okay, so here's our example. Kind of close to the heart, I guess you could say. Today's situation is called computer-based learning. The superintendent of a large school district wants to buy a computer-based math program for his district. Because the program is very expensive, he will randomly select some classes to pilot test the program. The response variable would be the average increase in grade level equivalent for the students in the classes. For example, if a student went from a 3.1 to a 4.3 by the end of the year, the student increased by 1.2 grade levels. So I have my H naught where mu is greater or mu is equal to 1, and then my alternative hypothesis is that mu is greater than 1, where mu is the mean increase in grade level equivalent for classes in the district. Alright, so we're going to use our 3 levels or 3 questions up here. So the first one was our significance level. Now we know that death is not part of this, even though boredom or math, or all the jokes aside about dying of math, we're not going to really die. But the thing that's going to influence us is the fact that it's expensive. Okay, it's going to cost a lot of cash. Okay, so that being the case, is that because it's it's expensive and it's a high influence, then we're going to want to move towards a 0.01 significance level because of the cash and the problems that it's going to affect into there. Okay. What we're looking at is our effect size. What are we actually going to be looking at? Okay. And what that means is even though our H naught and our alternative are whole numbers, the effect that we're looking at is we'll have, like, let's say that someone's at 1.0. We want to detect the fact that they're going up by that much, so a tenth. So our effect size is will be 1/10. So if we're looking at fractions, we're going to be looking at what's the next growth that we're looking at. Are we looking at the fact that somebody is going to hit that half-inch mark? Are we looking at the next penny? Are we looking at the next dollar? What exactly is the effect size? What are we looking for? Then power. What I put down here is I put this is something that will be determined to help with collecting the data. So the superintendent wants a probability that a test will detect an increase of 1 month in grade level equivalent. Alright, so what we're looking at is what exactly is the probability that we want this to be to work out for us. So the superintendent has decided he wants to be an 80% correct, right? We could change that to 90%, and that's what's going to help us determine what we're looking for. So that's the power. That's our 3 steps. That's how we're using our tests wisely. So email me questions, guys. We'll talk to you a little bit later.